Today's topic is calculating with significant figures. So if you remember, sig figs only apply to measurements. And it's important when we're calculating with those measurements that our answer doesn't become more precise or less precise than the measurements we used in the calculations. So we have some rules that we need to follow on how to round our answer at the end of our calculations. There's one rule we use whenever we're adding and subtracting. So let's start with that one. If we were to add these three measurements together, put them in the calculator is going to tell us the answer is 92.608. But if we look at our measurements very carefully, we'll see that the top number did not have a digit in the thousandths place. And the middle number doesn't have a digit in the hundredths or the thousandths place. So when the calculator tells us that we're going to have a 0 in the hundredths place and a 8 in the thousandths place, we don't really have confidence that those two numbers are accurate because we didn't have digits to go in those places in at least one of our measurements. So the rule when you add and subtract is you go to the last decimal place that all the measurements shared. So in this case, the last decimal place that they all have is the tenths place because 27.7 doesn't go any farther than the tenths place, which means our answer cannot go any farther than that either. So we're going to keep the 9 and the 2 and the 6, but we're going to cut off the 0 and the 8. So the digit directly behind the 6 that we're keeping as a 0, which is less than 5, so we're not going to round the 6 up, we keep it as it is, and our answer would be 92.6 grams. Let's try an example where we subtract. So if we had these two numbers and we put this in our calculator, the calculator will say the difference is 11.2 centimeters. But again, if we look at these measurements very carefully, we'll notice that both of them go as far as the hundredths place. But the answer the calculator gave us only went to the tenths place. But we know the answer all the way out to the hundredths place, so we need to include a digit in that place. So we would have to add a digit there, and the digit we would add would be a 0. So our answer for this problem would be 11.20 centimeters. So you notice that sometimes you need to cut the number off and get rid of some digits. Other times you might need to add some zeros on in the end to make sure that your answer goes to the last decimal place that all your measurements shared. The rule on how we round our answers when we multiply and divide is completely different. So if we were to take a look at these two numbers and we multiply them together, the calculator will say our answer is 0.1606764. The rule when we multiply and divide is we need to round our answer to the least number of significant figures. So that means we need to count the number of significant figures in our measurements. If you need to review how to count sig figs, be sure to check out my Chem with Kim video, Counting Significant Figures, because I'm going to assume for the rest of this video that you already know how to count sig figs. So looking at the top number, 3.084, that number has 4 significant figures. And 0.0521 has 3 significant figures, which means our answer has to have the same number of sig figs as the least number, which is going to be 3, because 3 is less than 4. Now the answer the calculator gave us has 7 significant figures, which means we're going to need to get rid of some of those digits. So we want to start on the left side looking at the number, and we're going to keep the first 3 significant figures that we come to. So we're going to keep the 1, the 6, and the 0 that came after the 6, and we're going to cut off the rest of the digits. Now, since the first digit we're cutting off is a 6, that's greater than 5, so we need to round the 0 that we're keeping up 1 place, and that would be 0.161 meters squared should be our final answer, because that has 3 sig figs, and that's all that we're allowed to keep. Let's try a division problem. So here we have two numbers. 3,825 has 4 significant figures, and 25 has 2 significant figures. which means our answer can only have 2 significant figures when we're done. Well, the calculator tells us the answer is 153, which has 3 significant figures. We can only keep 2. So we keep the 1 and the 5, and we're going to cut off the 3. Now, if we only write down 1 and 5 as our answer, we have shifted our decimal places for our numbers, which we can't do. Notice how in the answer the calculator gave us, the 1 is in the hundreds place and the 5 is in the tens place. But in my final answer that I've written down of 15, I have shifted those numbers over a decimal place. Everything has moved to a new decimal place. I'm going to need to add a placeholder 0 on the end so that the 1 stays in the hundreds place and the 5 stays in the tens place. But it's a placeholder, it's not significant. So I still only have 2 significant figures in my answer, not 3. Let's multiply 10.0 and 40.0 together. Well, since we're multiplying, we know we need to round our answer to the least number of significant figures. Well, 10.0 has 3 sig figs, and 40.0 also has 3 sig figs. The answer when we multiply them together is 400, but 400 only has 1 significant figure. So that's not going to work as our answer. If we write it as 400.0, that has 4 significant figures, so that's not going to work either. We need to write 400 in a way to show that it has 3 significant figures. So one way to do that would be to write 400 with a decimal point at the end, because when there's a decimal point in the number, trailing zeros are significant. The preferred way to write it, though, would be to write the number in scientific notation. So to turn 4 into 400, we would need to multiply by 10 twice. So it'll be 4 times 10 to the second. To make it have 3 significant figures, we need to change the coefficient of 4 to 4.00 to show that there are 3 significant figures there. Remember, with scientific notation, we just look at the coefficient when we're counting our significant figures. So the correct answer is 4.00 times 10 to the second, because that would have 3 significant figures. Now let's try an example that involves addition and division in the same problem and see if we can determine how we should round our final answer. So looking at this problem, we would do the addition part first because it's in parentheses. And when we add, remember we go to the last decimal place that they shared. Well, those two numbers in the numerator both go to the tenths place. So when we add them together, our answer should go to the tenths place. So it's 27.0, not 27. And then we need to divide by 3.654. And when we divide, we need to count significant figures. So 27.0 has 3 significant figures. 3.654 has 4 significant figures. So when we divide those two, our answer has to be rounded to the least number of sig figs, which would be 3. Now, when we actually get the number from the calculator, there's a whole line of digits in our answer. We're going to start on the left-hand side and count the first 3 significant figures, and then we're going to eliminate the rest of the numbers. Now, in this case, the first digit we're cutting off is a 9, which is greater than 5, so the 8 that we're keeping needs to be rounded up, and our answer should be 7.39. Now, the more you practice this, the easier it's going to get. I suggest in the beginning you keep a little note sheet next to you to remind you that when you add and subtract, you need to round to a decimal place. But when you multiply and divide, you need to round to a specific number of significant figures. So thank you so much for watching, and I hope to see you soon. Bye-bye.